Hi guys, welcome back. We're going to continue talking about solving systems, and we're going to do that easier method I've been talking about, elimination. So we have three ways to do this. We can graph, which we know can be difficult, especially if it's like a fraction answer. We can use substitution by getting one variable by itself. But elimination is a method a lot of students like. Now with elimination, we have to have the x's lined up, the y's lined up, the equals lined up, and the constants lined up. Okay, so they have to all be like on the same side together. Okay, we can't have them like all over the place. So like if this was written like x equals y plus 19 and x plus y equals 6, that wouldn't work because not everything lines up nicely. Okay, so that's kind of our first thing when we're looking at this. Okay, now what I'm seeing here is I'm going to add the two equations together, but first I want to make sure something is eliminated. So I can see here that negative 2y plus 2y would be 0 when I add the equations together. So this cancels. Well, x plus 5x is 6x equals negative 19 plus 1 is negative 18. Well, now I can divide by 6 and get x equals negative 3. Now I'm still going to go back to my original equation, okay? One of them, it doesn't matter which one because you could plug it into either one and still get the same answer. So I'm just going to plug it in here because I don't have to worry about multiplying. So we will have x minus 2y equals negative 19. Instead of writing x, I'm going to write negative 3. I'm going to add 3 to both sides. So this is going to become negative 16. And then I would divide by negative 2. So I get y equals negative 8. So my final answer would be negative 3, negative 8. Okay. Now if we look at this, I'll give you a second, write that down if you need to, pause the video. If we look at this next one, if I add my equations together right away, well, 3x minus 2x would be 1x, 4y plus 4y is 8y, so nothing cancels out. And we always want to make sure we cancel out one of the variables, not the constants. But if I were to multiply this equation by a negative 1, okay, that would become negative 3x minus 4y equals negative 18. So I can multiply an entire equation by a number and it's still the exact same equation. It's equivalent, okay? And I'm not going to do anything to this bottom one, so I'm just going to rewrite it so they're nice and stacked. Now, when I add negative 4y plus 4y, that cancels out. Now, I always make it so I can add the equations just so you don't have to worry about distributing a negative. So this becomes negative 5x equals negative 10. And then I'll divide by negative 5. So I get x equals 2. Okay. And then once I know that x equals 2, I can plug that into one of my equations. So I'll plug it into my bottom one for giggles. So negative 2 times 2 plus 4y equals 8. Again, I just plug that into this equation here. So this would be negative 4 plus 4y equals 8. I'm going to add 4 to both sides. And I'm going to get 4y equals 12. And therefore y equals 3 if I divide both sides by 4. So again, my final answer is going to be 2, 3. Okay. So if something doesn't cancel right away, we can multiply one or both of the equations to get something to cancel or to eliminate it. Okay. Let's go ahead and try this one. Okay. And again, I try to figure it out where I only have to multiply one of the equations, but sometimes you do have to multiply both equations. So I'm looking at 2x and negative 2x. I like when they're already opposite signs. So since one's positive and one's negative, I'm going to try and cancel x. Well, in order to cancel x, this would have to be a negative 2x. So I need to multiply it by 2. So nothing's changing with the top equation. I just like them to be stacked, so I move it over. Now, remember, I'm going to distribute the 2 to every single piece. If you don't distribute it to the equals part, everything's going to fall apart. Okay, so don't forget that. So negative 2x minus 6y, or plus 6y, there's no negative, equals negative 24. Okay, 2x minus 2x cancels out, so I'm left with 7y equals negative 21. And again, I always make it so I'm adding the two equations, so that's why I make one positive and one negative. Then divide by 7, y equals negative 3. Now you can technically subtract the equations, but I find students just forget to distribute the negative, and that makes things worse. Now once we know that y is -3, I can plug it in. I'm going to plug it into this top one here, so 2x plus y equals 3. And so we're going to have 2x minus 3 equals 3. So I'm going to add 3 to both sides. So I get 2x equals 6. So x equals 3. And remember, just because you solved for one first doesn't mean it goes first in the ordered pair. X always goes first in the ordered pair, right? So I had to find x before I could write my ordered pair correctly. All right, remember you can pause this video at any time if you need catching up. All right. Now this one is a little bit harder, okay? So we are going to go ahead and pick a variable to cancel. There's not a super easy variable to cancel because to make 7 and 5 look like each other, we have to multiply by 5 and -7. To make 12 and 8 look like each other, you got to multiply to get 24. So what I'm going to do is we're just going to decide to cancel x. Again, you can decide to cancel y, it doesn't matter. Okay? So in order to cancel x, 7 and 5 both go into 35. So I'm going to multiply the top one by 5 and the bottom one by 7. And one of them has to be negative, so when I add them together, they cancel, they eliminate. So I'm going to make the bottom one negative. It doesn't really matter. And then we're going to distribute the 5 all the way through. So this will be 35x minus 60y equals 22 times 5, so it'd be -110. Okay? And then if I distribute my -7, that's going to be -35x plus 56y equals 7 times 14, which is 98. Okay? So go ahead and solve it from there and see what you get. So again, if nothing eliminates, then I did something wrong. So this cancels to be 0, so we're left with -4y equals -110 plus 98, which would be -12. So then we divide by -4. So I'm going to get y equals 3. Now, when you plug this in, you could plug it into this equation, or one of your original ones, okay? One of the original ones is probably the easiest just because they're smaller numbers. So I'm going to plug it into my top one. Again, it doesn't matter. You'll get the same answer either way. So I'd have 7x minus 12 times 3 equals -22. Well, 7x minus 36 equals -22. So I'm going to go ahead and add 36 to both sides. So I'm going to get 7x equals, this would be 14, so x equals 2. Okay, so again, we can do all of these things to get rid of some of these values. And again, this can be slightly easier than substitution just because you have less fractions to deal with. Okay. All right, let's go on to our last one here. So Maddie spent $24.75 to buy 12 flowers for her mother. Roses cost $2.50 each, and daisies cost $1.75 each. The bouquet contained roses and daisies. How many types of flowers did Maddie buy? Apparently I can't keep names straight. I know I've done this on the last several notes, so we'll change that to Maddie. So we did this by creating two equations. So we did roses plus daisies equals 12. And then to find the cost of just the roses, you would take $2.50 times the number of roses. To find just the cost of daisies would be $1.75 times the number of daisies would equal the total $24.75. Okay, so if we want to do elimination here, I would say let's cancel D just because we haven't canceled the second variable. So I need to multiply this top by -1.75. Again, since there's just a 1 in front, it's a little bit easier to deal with. So I'm going to have -1.75r minus 1.75d equals 12 times -1.75, which would be -21. And then we just bring our second equation over just so they're stacked. Okay, again, remembering that all the variables need to be stacked together, and the equals need to be stacked together, and the constants need to be stacked together. Okay. 250 minus 1.75 is going to be 0.75r. The d's cancel out, so I'm going to get 24.75 minus 21 is going to give me 3.75. We're going to go ahead and divide by the 75 cents. And 3.75 divided by 75 is 5. So there are 5 roses, which makes sense because we can't have a decimal amount of roses. And if we have 5 roses, I can plug that back into my equation, r plus d equals 12. And some of you could do that in your head. So 5 plus d equals 12. So there would be 7 daisies. Okay. I hope this video finds you well, and we'll talk to you later. Bye.